Assalamualaikum, peace be upon to you. This is video demonstration for section 5 group 4. Okay, this is BEJ20801, which is electronic engineering laboratory 2. We are going to discussing about the lab first control, which is introduction to simulating. Okay, this is control online, lab 1, which is introduction to simulating. My name is Muhammad Ali Hakim bin Azami. Matrix number is DE220124, and my group lab partner, which is Sundus Awil Khalif, AE200087. Okay, I'm going to introduce you what this lab is about. Introduction to Simulating, which is make us familiar with the simulating application. After this laboratory, we're going to able to create a block diagram of control system, measure efficiently parameters of transfer function, and demonstrate good team skill work. Okay, this is Simulating. Simulating is, you can see, this is Simulating, an extension of MATLAB in a graphical way. Okay, we're going straight for the experiment procedure. Okay, for part A, we needed to do the tutorial exercise. I've already done it, but I can show you again for proof. Okay, first we need to open the website here, which is on the left side of the screen, and we're going to make it one by one. As usual, if you want to take some this, you need to simulate. You need to create the block diagram. Is transfer function from continuous, and from source, which is step, scope. Oh yeah, step, and thing, which is scope. Okay. I believe we need to change the denominator here, which is 124. Apply. And then step, make sure it's the same as on the left side. So if you see like this, you can drag it so you can see the number. Okay, then if you run, which is Ctrl T, you can see from the scope. Yeah, like this, there will be the graph, which is the same on the left side. Yes. Then if you want to, like here, it said not that the step response does not begin until t equals to 1. So we need to change the denominator again, which is 120 and 400. When you apply, then you Control Run, Control T, it will change the scope, same like this left side. But if you see like this, it become narrow. We want to make it more nicer, so we can make it, can change via model setting. Go to the start time, which is start by 0.8 and 2. When you apply, you will see the scope is now different. Oh, you need to run first. And as you can see, it will become much smoother like on the left side. Okay. For the building a block diagram, it's easily as like that. So we need to make building a system. So we need to make everything like before. This is 0. This is 10. To make it simple, we just make a new button. Okay. And for the building system, as you can see, we need to make like this picture over here. Let's go to the library and drag it. Is most of it from simulating lah, because we need Simulink, right? PID, controller, transfer function, what else? Map equation, which is gain and sum. And last but not least, which is the sink and source, the scope and the source, which is step. Okay, after done it, we need to make it right on the left side. So we just need to rearrange them, make it more nicer in a way. Maybe the controller, and transfer function. Last one is scope. Make it so we can show the transfer function name. Okay, also gain and step. Okay, so first things first, we need to change the setting here. We need to modify the system. Where the sum we need to plus and negative. Okay, and for the gain, if you look closely, it says here we need to change it to 2.5. And also the PID we need to change it, which is over here. Change the proportional gain to 1 and the integral gain to 2. Okay, apply and okay. For the transfer function that same like before, which is 1 to 4. And we continue the the linking. Alright, we need to rename it to PID controller. PI controller. And then as I believe here we need to have a transfer function we need to change it to plant. Okay, later on we need to link it and make a feedback. Type here. I mean drag and go for the scope. Okay, and I believe we need to you can rename it R here, rename it E here. For the plan is U, and after the plan is Y. If it looks messy, we can rearrange it more so it make it good. Alright, we can save and we can start to run. Control T. You can see on the scope. Yeah, same like the left side. So we can take in variable from MATLAB. As you can see, we can open the MATLAB over here. This is for the beef, for the part. Okay, we need to clear. Okay, for this one, we can change the gain via the command window. So you can make it gain as K. Okay, apply. So as you can see, it doesn't have any variable K, does not exist, right? We can go for in the MATLAB. Identify put K as variable K to like in the MATLAB. In the website, it needed us to change it to image display. Okay, K 2.5. K 2.5. Okay, and hold on a second. Refresh. Okay. After with K2.5, we need to check first. Okay, here it's already changed, which is K2.5. Okay. So we go back for this one. We run it again. Let's see if it's still the same. Yeah, still the same. So we can change it by in the MATLAB over here. So there is a connection between MATLAB and Simulink. Just need to know that we need to select the Simulink, which Simulink that we want to change the variable. So if you can see, it asks us to make k equals to 5. So you can go over here in the Simulink k equals to 5. So basically you can change any variable in the MATLAB. Okay, and then we can go for run and go for scope. See, save. This is k equals to 5, which is the gain equal to 5. Okay, so for the part A exercise, already done here. Okay, for the part B, which is modify the transfer function, this one we ourselves need to determine our own transfer function and make our own system, which is here we need to modify the transfer function. So if you can see, I already done it in this step 1. It's almost the same like in the exercise, right? Yes, it's identical. So this we can go down. So in this part B, our lecture asks us to let instructor ask us to make our own transfer function, or you can choose here. But we decided to choose here, which is transfer function plan equals to denominator 1331 over here. So okay. And then we need to determine our own maximum gain K max. So we decided to take K max equal to 10. K equal to 10. So after done that, first we need to, for 6.1, we need to choose times transfer function, done. And the second one, we need to define our own K max, which is we take it K max equal to 10. And then we need to sketch the scope result. So this is I already done. K equal to 0, 2.5, 5, and 7.5, which is we refer here. The first one we need to make the K value to 0. Next one is K max divided by 4, K max divided by 2, and 3 K max divided by 4. Let we see. K over here is defined by, we need to change first. In the system, we make K equal to 5. So we need to modify it to K to 0. Okay, so we take it here. K equal to 0. So we can control T, which is we're going to. Okay, so we open the scope. Let me see if it's the same. Yes, this is the same. When K equal to 0, there's no signal wave or anything activity. Right, the same way. Then we need to go for K max equal to K max divided by 4, which is K 4 divided by 4. Okay, which is 2.5. We double check with here K gain is 2.5. Can run and check the score. Is it the same? Yes, it's the same. And then we go for K equal to 10 divided by 2, which is 5. And then we can run it. Still the same on the left side. K max is 10 K equal to K max divided by 2. And then for the last one, which is K equal to K multiplied by 10 divided by 4. Then we run. It's still the same. Okay, the same one. So that's for the scope result. We just take the picture over here and we put it there. Okay, that's one done. For now, the 6.4, which is the system transient response characteristic. So far, from what I remember, we can measure itself from the scope graph, but we want to take the most accurate data. So I take the scope data over here and from the properties. No. Try go to model setting. I went into data types, data and import export. I export the data into the MATLAB. So as you can see, it's go out over here. Hold on a second, I need to change the. So in the MATLAB, I make it so when the scope data already done, it will transfer to here, which is there. We got it, scope data. You can go here, configuration properties, and login. Log data to space, give the variable name, which is scope data, and we save it as that way. Okay. So when you run, the data here will transfer to the workspace. So from here, we need to know the MP, which is the overshoot percentage, the TR, rise time, and the TS, which is setting time. So we go for step info, scope data, which is equals to 2, and scope data equals to 1. Okay. Oh, I think there is something wrong. Oh, I forgot the. Yeah. Okay, wait. So, yeah, enter. We show us the rise time, the setting time, and the overshoot. That is one. Okay. We can refer it to here because in the scope, in the graph, it doesn't have any peak, so the overshoot will become 0. And the setting time, we can take it from the graph, which is, I believe, rise time is subtracting 10% of the final value from the 90% final value. So from here, maybe here, and the setting time right before graph becomes stable and linear. But if you can see, the setting time is over in the end because there's no sine wave which is it become stable or not. So we take it the last one, or you can say we refer to the step data, step info. Okay, because for the better result, we use scope data from the scope. Alright, this is for the k equals to k max, k equals to 3k max divided by 4. So if you change the gain into, for example, k equals to 0, then you run it. The scope data over here will transfer to the left side. Can go for step info, scope data to scope data 1. See, you can see there's no rise time, no setting time, and overshoot because no peak. So we can say we can cast this type info for our data for this lab. And also you can see on the, if you make it k equals to 10 divided by 4, which is 2.5, you run it on the scope, and this one we just the copy paste, we can go up. Yes, okay, just step everything. So you can see here there is an overshoot over here because there is a peak, and the setting time, because the setting time is very high because there is no stable in the waveline. Rise time we can conclude it. Okay, I think that's clear now. Let's see if there anything more. So after we include it, okay, we can get all the data for the table. So for 6.5 discussion analysis, we already did the tutorial, and then after the tutorial we make it into the part B. So we choose the transfer function and the k max, which is 10, and then we go on for the k equals to 0, k equals to k max divided by 4, divided by 2, and 3k max divided by 4. After that, after we go for scope and scope data, we need to measure our own overshoot percentage, rise time, and setting time. And this is how to take the rise time, setting time, and also the overshoot. Okay, and then if you can see up here, we got the result from the scope result. Okay, that's for the 6.5. I think that's all from me. Thank you.
Hi, Assalamu alaikum. My name is Sundus Al Khalif. My matric number is AE200087. Today, I want to present my part of lab. So let's start. Describe the function of the step input transfer function and the scope program diagram in the context system and response simulation. The function of the step input block is cast of generate to stay function as the input to the system being analyzed, and step function is frequently used input signal. And the system analyzes because it is simple and well-defined signal that enables easy observation of system behavior. The transfer function block represents the mathematical model of system being analyzed. It describes the relationship between the input and output signal of the system in the frequency domain. The transfer function block is used to specify the transfer function of the system being analyzed. The scope block is used to visualize the system of responses to input signal. The scope block provides graphical displays of the system output over time, which enables the users to observe the system behavior and assess its performance. Some of other type of source that can be used in the real-world applications, such as RAM input. RAM input is a signal that increases linearly with time. It is commonly used in modeling systems where input changes gradually. Sun input is one of the other used real-world applications. And this periodical signal with tensor waveform. It's commonly used in modeling systems that exhibit periodic behaviors such as electrical circuits and mechanical systems. How MATLAB Simulink replaced computational test instrument lab, and some of examples in explanations. MATLAB Simulink is control tool for simulating, modeling, and analysis dynamic system, which is capable to simulate the complex system in the real time. It can replace many of computational testing instruments that are traditionally used in the lab. And here are some of examples of how MATLAB Simulink can replace computational test instruments. First one, oscilloscope. Oscilloscope is a common test instrument used to display voltage performance, voltage waveform. A simulacroscope below can be used to visualize and measurement outputs of simulated system in the real time. Function generator, also some of them supplements MATLAB Simulink. It is test instrument used to generate different types input signals. Simulink signals generators below can be used to generate a wide range of input signals, including sine waves, square waves, and swath waves, and more. In conclusion, Simulink measurement below can be used to measure these same parameters in simulated system. Additionally, Simulink can also perform advanced analysis and optimization of the simulated system, which may not be possible for computational test instruments. For example, Simulink can be used to design and optimize control systems for various applications such as robotic aerobases. In summary, MATLAB Simulink can replace computational test instruments in the lab by providing powerful tools simulating, modeling, and analyzing dynamic systems. It can simulate complex systems in real time, generate various input signals, and measure electrical parameters. Additionally, Simulink can also perform advanced analysis and optimization, making it valuable in various industries. That's all. Thank you.